Alrighty. Okay, here we go. Let me see here. Yeah. Okay, so okay, and that should probably work. Let's make sure that it did. 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 Okay. All right, then I got this. Okay. And then I got this. Okay, there we go. All right. There we go. Okay. Lots of different things going on. Okay. All right. Hello, hello, hello. Hello, everyone. All right. Okay. All right. Hi, everybody. Sorry for the little bit of a late start here. I was just making sure of one thing there. Hope everybody's doing well today. Okay. Okay. All right. Hello, everybody. All right. Okay. We're gonna have to go get started here. Okay. Okay, let's get started today. Welcome back to Tuesday. All right. hopefully everybody had a nice weekend. All right. So today, we're gonna go ahead and continue moving forward here within chapter 4. Okay. We're gonna again finish. We're gonna maybe finish up a section and a half here today, as there's a lot in section 4.5. There's a lot of different concepts here that they do talk about in section 4.5. But I want to kind of pick up where we left off last time, which was talking about. We did a little bit of multiplication of decimals. So uh, that's what we ended up doing last time. So for what we're doing here, in this particular case is we're going to take care of a few more examples of multiplying a couple of decimals together. We'll talk about the keys here once again, and then we'll get into the following section after that, which is division of decimals. So we're going to talk about extensively about that and show you how we can do that and put that together. All right, so let's go ahead and do that right now. Mm-hmm. Okay, let me get this done. Okay, there we go. All right. Okay, so let's go ahead and start off with the handout here from last time. All right. And so let's talk about, again, a couple of more examples here. Again, we counted the number of decimal places to multiply a couple of decimals together. I want to start off with just a couple more examples here that may be a little bit tougher to kind of get used to. So let's go ahead and met that out and see what that's all about. Okay, so, all right. So let's go ahead and do this one here. Let's do, I could do that one. So let's do 11.62 times 4.01. Okay. Now again here, remember that when we multiply two decimals here together, it doesn't matter, again, lining up the decimals doesn't matter here. That only applies to addition and subtraction. All right, so remember what we need to do here. Again, we need to count how many decimal places that there are in each individual number. All right. So, can anybody tell me how many decimal places are there in the first number that we see here for 11.62? How many decimal places do we see here in 11.62? All right, 2. That's correct. So there's going to be 2 decimal places here. All right. And I wonder if that's on or not. Check. Oh, that is on. Sorry about that, folks. Okay. All right. So there's 2 decimal places here. And how about 4.01? How many decimal places there? How many decimal places in 4.01? All right, so once again, 2. Okay, that's correct. All right, good stuff. Okay. All right, both of you are correct. Very good. All right, so what we want to do here is, once again, we're going to go ahead and add these number of decimal places here. So we're going to have 2 decimal places plus a new 2 decimal places here. We're going to have 4 decimal places here. that we want to move over at the end of the problem. So we place this little factoid in our back pocket, and we're going to be able to use that a little bit later once we figure out what this whole thing is going to be. So one of the things that we talked about here specifically is we talked about uh, how much what we have to do next here with this particular problem, which was again just ignoring that the decimal places even exist and just basically straight up multiply. So we want to just go ahead and say, all right, this would be 1162 times 401. And then you just want to go ahead and multiply straight up, ignoring that there are any decimal places even there. Just take it as they were two regular whole numbers. And then we'll see what we get. So if we go through the motions here, again with times 1 is pretty easy. You get exactly what you start with. So and we use our little cross out method here, so we know to shift over by 1 to the left. 0 will net us 0 for all of our guys. So again, that one's pretty easy. Okay. Put a little cross out here. All right, now 4 is going to be a little different. 4 times 2 is 8. 4 times 6 is 24. We'll carry the 2. 4 times 1 is 4, plus 2 is 6. And 4 times 1 is 4. So putting that all together, we get 2, we get 6, we get 9, we get 5, and we get 6 here, and we get 4. Okay, so multiplying 1162 times 401, not too hard. Again, we get 465,962. All right. All right, so now that we have that, we now start with moving our number of decimal places here. Now remember, we have to move the number of decimal places here over to starting all the way from the right. Okay, so we always start all the way from the right, and we move left the number of decimal places that we had found earlier. So we're going to move left again 1, 2, 3, and 4. So we're going to go ahead and put that decimal point right there. So then, again here we have 46.5962 would be our answer to this problem. And that's how we get our final answer for that. Okay, any questions about that? Awesome. I'm glad you really do. Math is nice and fun. It can be fun, even though it's dry, but it can be fun. All right. Let's go ahead and try another here. Okay. Let's go ahead and try another here. This time, I would like you guys to go ahead and give this a try. Again, now that I've given you a backdrop for this. So let's go with letter D here. Go with 58.6 times 17.4. So I'll give you guys a minute or two to go ahead and give this a go. All right, and once you got your answer there, go ahead and put that in the chat. Catherine, Catherine, if you're there, I sent you a whisper there. If you could go ahead. Yes, that is a 17, Yvonne. That's how I write this, my sevens, because my sevens used to look like twos. So that's why I write a little dash there for the 7. No problem. Yeah, so Catherine, please check your whispers there. You can find that at the top of the screen. Yeah, you're welcome always in this class, though, Roses. That's perfectly fine. Okay, 1019.64, okay. We're just sitting here and having a good time. So anybody's welcome here. So that's how it rolls. Okay, 101.98.14, okay. As long as you want to learn something, anybody is welcome in this channel. So that's how it rolls. Simple enough. All right. Anyone else? Okay. Good, good. Okay, let's take a look and let's see what we're working with. Okay, so here in this particular instance, if we take a look here at each one, we have one decimal place on each individual number. Okay, and so here we get, again, two decimal places overall is what we're going to be looking at. So at the end of the problem, we're going to be moving two decimal places in some form or fashion. Okay, now, next part is to actually multiply 586 times 174. Again, we're just ignoring that the decimals even exist. So we're just going to not, again, that's the next part here. We want to just ignore that the decimals are even there in the first place. So here we have, we go ahead and just go through the motions of multiplying each one out. So 4 times 6 is 24. Oh, that would be a problem. Oops, the extra number there of the 1 threw off your answer. It's okay. It happens. We're all human. All right, so that's 24. This is 32 plus 2, which is 34. We have 4 times 5, which is 20. 20 plus 3 is 23. All right, put an X here. 7 times 6, which is 42. 42, so we have 56, and we have 60. And 35 plus 6, which is 41. Oh, not yet. And then we put a double cross here. And they have 1 times everything is just that everything. So we're just going to put that just like so. All right. We'll go ahead and add down. We get 4 plus 0 plus 0. That's 4. 4 plus 2 is 6. 3 plus 6 is 9. 2 plus 1 is 3. Plus 8 is 11. So we carry the 1. So we get a 10 here, just like so. All right. And as we can see here, we move 2 decimal places here, starting from the right and going left. So we go 1, 2. So the correct answer is indeed 1019.64. All right, and that indeed is going to be our final answer. All right, great, nice job. Are there any questions about that? again, if you have any questions, go ahead and type that out in the chat, or if you don't, just type out no, and then we'll move on. Oh yes, by the way, sorry. One thing I forgot to mention to you guys that I guess I probably should have said from the beginning here is that I went ahead and I extended the test out for 2 more days if you haven't finished. Seems to be a lot of stragglers, so I extended it out for just 2 more days to finish up your stuff. So if you have a second chance, if you want to improve your score, you can. You can go ahead and do that there. So just 2 more days until Thursday, and then that should be fine. So, okay. All right, no questions. Let's go ahead and move on here. Let's do it. Okay. Hello, James. I hope you're well. All right. Let's look at the next section here. So we're going to go ahead and move on here into the next section. And so let's go ahead and talk about that right now. Okay. Okay. So this is the last section here of this particular chapter. This talks about section 4.5, all right, which is dividing decimals. Now there's a lot of things in dividing decimals that we're going to have to kind of get to know. So we'll get to know how those things work out. It's really not too hard. It's just, again, just have to make some adjustments. That's all. Okay. All right. Okay, so let's go ahead and take a look here at how we can divide decimals. Now, dividing decimals here in terms of writing out the work is pretty important, at least to understand the basic concept. So let's talk about the steps about how to do that, and it's not too hard to figure out. All right. So as you can see here, dividing decimals by whole numbers is pretty straightforward. Again, if you take that first question there, 21.93 divided by 3. So we're just going to look at each part here. Now the important part here is exactly what each one of these numbers represent. And as you see there, 21.93 is the dividend. Again, as a reminder here, the dividend is what the number you are dividing. Okay. And 3 here is once again going to be the divisor. Again, the number you are dividing by. Okay. Now, as we can see here, it always goes like this. Again, we always put the divisor, remember the divisor here goes on the outside, and the dividend goes on the inside. Now, for the purposes of actually doing this out, it is actually pretty important that we know the position of where each of these numbers need to go. Now, again, it's no different than what you talked about when doing, say, some basic division. But this will be important when we deal with like dividing by other decimal numbers a little bit later. Let's go ahead and try this out here, and we'll also talk about the key behind how to doing these particular guys. So let's do it. All right. Okay. So if you see something like this, again, remember, it could be 21.93 divided by 3. That looks pretty terrible. Let's try that again. 21.93 divided by 3. Remember, it can be written this way. It can be written this way, 21.93 divided by 3. So then again, that's a different way. Or again, the other way that you can write it here is exactly what I said here. Okay, the divisor on the outside, the dividend here on the inside, just like so. And this is the way that we're going to go ahead and write it, is using this third method here, as it'll be helpful if we go ahead and do this out by hand. Now, The important part here is something that we talked about earlier in this chapter. When we talked about adding and subtracting here, we talked about lining up the decimals. In this case, that's going to happen as well. All right, so the key is going to be two things. We're going to talk about two keys. Key number one, we're going to make sure the divisor, or again, the number on the outside, is a whole number. So we're going to first make sure that that divisor, that number on the outside, is a whole number. All right. And the second key that we're going to mention here is that we're going to line up the decimals after confirming. Key number one. So we're going to line up the decimals after confirming key number one. All right. So we make sure that you got the whole number on the outside. Whatever number you got on the inside, you're like, okay, cool. All right, we can line up the decimals and we're cool with that. Okay, so that's going to be our main goal here for these type of problems. So let's take a good look here. So if you see here, we have a whole number here on the outside of 3. That's fine. We're going to line up the decimal here. So if the decimal's right here, now that we've confirmed we have a whole number here on the outside, we're going to put the decimal right up here as well, as that's going to be part of our answer. Okay, so next, we just go ahead and figure out, again, just do regular division here. Regular, plain old division. We've taken care of the decimal part, so we don't need to really worry about that too much anymore. So we just, again, figure out how many times 3 goes into a certain amount of numbers. So 3 goes into 21, so it doesn't go into 2, but 3 goes into 21 how many times? How many times does 3 go into 21? All right, 7, that's correct, okay? So again, 7 times 3 is 21. So we're going to put a 7 up here. So we got 7 times 3 is 21. Again, we subtract. That's going to be 0. Now don't mind the decimal here. We're just going to bring down the 9 just as normal though. Even with a 0, that's okay. So I'm going to bring down the 9. Now we just rinse and repeat. So again, 3 goes into 9 how many times? All right, 3, that's correct. Good. So then we do 3 times 3, which is 9, and that's okay. Subtract here, we get 0. Bring down the 3. And 3 goes into 3 basically 1 time. Okay, and so now we found our answer here. Our answer for this problem is going to be 7.31. All right, and that's your final answer for that. Okay. All right, any questions about that so far? We're going to do some more problems here, but again, with just whole numbers to start with, so. Any questions? Hopefully that's pretty straightforward. No? Okay. All right. Well, let's go ahead and do the next one out here. All right. So the next one out here is going to be talking about, let's see, which one should I do? Sure, I think that's okay. Let's go ahead and do that one. So let's do this one here. I'll go ahead and put that on the outside there. So I'll put 11 out here. Hey, thanks, James, for the follow. So let's put a 278.3. All right, just like so. All right, so we can confirm that the number on the outside is, again, our divisor here is a whole number, that being 11 here in this case. Again, as you can see, we want to line up our decimals. So we're going to say the decimal right here. So we're going to line up that decimal right about here. Okay. Now, let's go ahead and find out what we're going to get here when we divide by 11. So 11 does not go into 2, but 11 definitely goes into 27. So how many times does 11 go into 27? How many times does 11 go into 27? All right. The answer definitely is 2. Very good. That's right. So I'm going to put the 2 up here. So 2 times 11 is 22. So 27 minus 22, which is 5. And we'll bring down the 8. All right. Same question again. How many times does 11 go into 58? All right, nice. The answer definitely is 5. All right, cool. So I'm going to put a 5 there. All right. Simple dimple. All right, so 5 times 11 is 55. We'll subtract this, so we get 3. Bring down the 3. All right, and then finally, 11 goes into 33 how many times? All right, 3 times. All right. And so here we get 0 as left over. All right, so that's fine. So we get 25.3 as our final answer. And there we go. We got it. All right. So as you can see there, it doesn't take too long to do. It just, you know, pretty straightforward. Okay, good. All right. Now, let's do the next problem here. Yeah, another problem. Let's go. Oh, maybe I don't want to do that. Okay. Now, the next problem we're going to do here is right here, this second example that you see here on the handout. So we're going to take 1.5 and divide it by 8. Okay, so 1.5 divided by 8. Okay, so first and foremost here, let's answer this question here. What number goes on the outside and what number goes on the inside? Okay, so what number goes on the outside here in this case? What number goes on the outside here? Okay, 8 on the inside, 1.5 on the out. Wait, reversed? Well, one of those two is correct. I think you were correct the second time. Hey, nice. Okay, so correct. Anytime, whatever we're dividing by, our divisor, right, is going to go on the outside. So what we're dividing by here. And that's correct. 1.5 definitely goes on the inside, just like so. Perfect. All right, so absolutely right. All right, so whatever we're dividing by here, in this case, we're dividing by 8. That needs to go on the outside. And then the dividend here of 1.5 will go on the inside. So a common mistake people usually make, again, why Why was that your first guess? Because you always think that the bigger number needs to be divided by the smaller number. It's always kind of like that, that little habit that you kind of get into. But in reality, you just have to read it where the numbers properly go, regardless of what the order is. So a good thing to remind yourself of, just in case. All right. In any case, let's go ahead and take a look here um, at this particular example. Now, in this particular example, we're not going to get a whole lot out of this. Now, what do I mean by that? Well, I'm going to still line up my decimal point just like I did in the last two examples. That part isn't going to change. 8 can't go into 1, so if you want to, you can put a 0 here for 0 point something. Now, we could also go ahead and what level of math is this? This is pre-algebra. So pre-algebra with some basic arithmetic. Uh, so we talk about 8 going into 15 here. Now 8 goes into 15 one time. Okay. The problem is that we would take 15. This is actually, you could read it like 15. Okay. And so you'd have 15 minus the 8 here, and then you'd get 7 left over. Now the issue with this is that, well, we have a remainder, so can I write like, say, 0.1 remainder 7? I mean, that doesn't make any sense, unfortunately. That's not how it works necessarily, unfortunately. So what we need to do here in this particular case is, if you have things kind of left over, let's say we have all this blank space off to the right. So you can see, like, we have all this blank space off to the right of that 5 there in 1.5. So this is a note I'm going to add here in this case. So if you have stuff left over, place as many zeros as you need until you solve the problem on the inside. Okay. Now I guess I'll be excuse me. I guess I'll be a little bit more precise. Place as many zeros as you need, and let me go ahead and at least say this to the right of the number until you solve the problem on the inside. So what I'm basically saying is this. I'm just taking this particular side here. I said, okay, let me add a few more zeros. I can add as many zeros as I want until I am satisfied that I get down to getting, hopefully, a remainder of 0. Now, you may not get to a remainder of 0, but you don't have to necessarily go on forever. Okay, so one thing is, you do not need to go on forever. Okay, so one of those things that people just say, I'm just going to keep adding zeros. So, like, add 3 or 4 zeros to start with, and if you still got some other decimal places, then you can add a few more zeros to that. Okay, so what we're going to do here is we're going to take this last part here. We're going to bring down this 0, and we're just going to go through the same stuff once again. Okay, so here we're going to say, okay, 8 goes into 70 8 times. So that'll be 64. Bring down the next 0. And again, you can repeat as many zeros as you want. 8 goes into 60, let's see, 7 times. All right, so 7 times 8 is 56. So we got 4. We're going to bring down that 0. And then finally, 8 goes into 40 5 times. And there we go. So that'll be 40, and then that basically is equal to 0. Okay, so That is, that's fine how we found that. This shouldn't be too much of a problem. Okay. All right. And so that's our final answer here is 0.1875, sorry. Oops, my bad. All right, 0.1875. Okay, any questions about that particular example? Absolutely, we could do another one of those. No problem, not at all. Let's go through another one together. That sounds just fine. All right. Sure. All right, so let's do letter C, okay? So let's do letter C. That's fine. So we're going to have 30 here on the outside, and we'll put 259.5 on the inside. And again, if you want to, and again, it's your choice, if you want to, you can add zeros beforehand if you feel like you may need to use them. So let's add a few zeros here. I don't know how many we'll need. You know, we may need 3, we'd 84, you know, whatever the case may be. All right. So let's go down the line here, and let's see what we can get. All right, so we can line up our decimal here for sure. So that's where our decimal is. Now 30 does not go into 2. 30 definitely doesn't go into 25. But 30 does go into 259. How many times does 30 go into 259? All right, 8. That is correct. Good. And what is 8 times 30? What's 8 times 30 there? 240. Okay, good. So we have 240 here. Now if we subtract this, okay, we're going to get 19, and we'll bring down the 5. All right, so far, so good. That's perfectly fine. Let's answer the same question again. How many times does 30 go into 195? Okay, the answer indeed is 6. Okay, so we get 6 times 30 here. What's 6 times 30? All right, 180 straight up. Cool. All right, so here we're going to get 15. Bring down that 0. My 5s look terrible today. Let's try that again. There we go. All right. So we got 150. And then how many times does 30 go into 150? How many times is that going to roll? 5. Awesome. Okay, that's correct. Anybody can chime in, so that's good. So 5, 5 times 30, 150. Spot on, and we got 0 as our remainder here. So final answer here is going to be 8.65 straight up. There we go. Okay. All right. Any questions about that? No problem. You guys ask, and I will certainly answer. That's how it's done. Any question? Oh yeah, no problem, Hannah. We are in section 4.5. So section 4.5. We just finished. We just did a couple of examples from section 4.4 talking about multiplication of decimals. So we just did a couple of them because we did a few of them last class as well. Can we do one really fast? Okay. Actually, yes. I think I know how to do this. All right. All right. Let me go ahead and show off one thing here really quick then. How can you confirm that something is how can you confirm that something is an answer here? So let's say, for example, here in this, let's go with this second example. Actually, we found that the answer here was 8.65, and you say, okay, can I confirm that this is really the case here for this particular problem? Well, the answer is yes. Okay, again, you can use the multiplication in order of which to do so. Okay, so basically, you could take 8.65 and multiply by 30, and Uh, and we should get 259.5. So again, this is a good way to kind of check, and I know we don't talk about checking the answer too often, but we got 8.65 times 30. Now, one thing that I do want to remind you about here is if you, one thing I want to remind you about is that if you have 30 here, okay, um, yeah, we refreshed. Okay, that's good. I'm fine on my end. So, uh, remember that 30 here has 0 decimal places, okay? So remember that 30 has 0 decimal places here. There are actually no decimal places here because there's nothing next to the decimal, whereas the first number here has 2 decimal places. Okay, so just want to serve that as a reminder here that we're going to have a total of 2 decimal places. Every whole number always has 0 decimal places. All right, and then we go ahead and multiply 865 times 30, and we'll see what we get. So we get a bunch of zeros here to start with. 3 times 5 is 15. 3 times 6 is 18, plus 1 is 19. And 3 times 8 is 24, plus 1 is 25. So here we're going to get 0, 5, 9, 5, and 2. And all we have to do now is to go ahead and move over 2 decimal places. So we go 1 and 2. So our final answer here is going to be 259.5, which is exactly what we wanted here from our previous problem. So hopefully that gives you a little good of a refresher there about how to do the multiplication in that particular instance. There any questions about that? Cool. All right. Okay. All righty. Now, we're going to do one more division problem here because certain problems here ask you to say round to the nearest decimal place. In this case, if we take a look here, rounding to the nearest thousandth as it asks in this place. So it says divide 4.7 by 3, round the quotient to the nearest thousandth. Write extra zeros in the dividends so you can continue dividing. Okay, so let's take a look at that problem there. Oops. And let's see how we can do that. Okay. So we're going to take 4.7 and we're going to divide it straight up by 3. Okay? So that's what we're going to use here. Now, 4.7 divided by 3 is a little bit different than maybe what you're normally used to. It says to round to the nearest thousandth, okay? So it says round to the nearest thousandth. All right, so can anybody tell me here, how many decimal places is the nearest thousandth? How many decimal places is that? Is that, let's say, 1 decimal place, 2 decimal places, 3, 4, 5? How many decimal places is the nearest thousandth? Okay, Yvonne says 3 with the question mark. Okay. Anybody else? Okay. 4? Oh, now it's suddenly changed to 4. Okay. No, 3. Now back to 3. I'll agree. One of those two is correct. One of those two is correct. So the number of decimal places here in this case is going to be 3. So 3 decimal places here. Okay? That's correct. Yes. So we have 3 decimal places here. So with 3, again, we have tenths, we have hundredths, and we have thousands. Okay? So 3 decimal places is the way to be. So let's set up our problem here. We're dividing by 3, so that 3 needs to go on the outside. And we're going to go ahead and put 4.7 here on the inside. Okay, now since we want 3 decimal places, well, let's add a few more zeros. So I'll add a few more. There we go. And we're just going to see what we end up with. So simple as that. All right. So 3 goes into 4 one time. Pretty easy. Oh, we've got to line up those decimals too. So we get 3. Get 1. Bring down the 7. Okay, so how many times does 3 go into 17? How many times does 3 go into 17? 5 times, okay. Good. 5 times 3 is 15. So we get 2 and then 0. All right, how many times does 3 go into 20? How many times does 3 go into 20? Oh, okay. It's like 66 times. Holy moly. That's a lot. That's a ton. All right, 6 times. So we get 6 times 3, which is 18. Okay, good. And we get 2, and we get another 0, so we get 20 again. And as you can see, what will happen here is we're going to keep repeating the 6 because it's going to keep repeating the same pattern here over and over again. So we're going to have 1.566. We'll put a 0.666. All right, just like so. Okay. Now remember, we need to round to the nearest thousandth. So we need to round to 3 decimal places. So if we took a look at our answer here, what we have is 1.5666. Okay, so what do we round this to? If we're going to round it to the nearest thousandth, what does that round to? What number does that round to there? Oops. No, come back. 1.567 is correct. So remember, we did this technique here where we circled the number here about what we wanted to round, and then we underline the number there to know which number that we're going to use to determine if we keep it the same or we're going to round it off. So in this particular case here, we want to round it up by 1. So this 6 now becomes a 7. Remember, everything after that is a 0. So essentially, we're going to get 1.567 to be our final answer for this problem. That's correct. Good. All right. Any questions about that? All right. All right, so now this time, let's go ahead and have you guys give it a try. So I'll have you guys do one of these problems here, so you'll have a chance to give it a shot. So let's have you guys give this letter C a try. So let's go ahead and do 10.22. We'll divide that by 9. So 10.22 divided by 9. All right, and I want you to round again to the nearest thousandth. All right, so round to the nearest thousandth. So 3 decimal places, just like we just did. So let's go ahead and take a minute or two. Again, once you got an answer, go ahead and put that in the chat. You should be okay. So. Yes, thank you. Okay, go away. All right, it's fine. All right. Don't worry, take another minute or so. It's fine. Oh, there we go. All right. All right, 1.136. All right. Okay, looks like we got the same answer there. Okay, very good. Okay. Now, like I said, if you didn't get it right away, or again, it took you a little more time, that's not a big deal. Everybody has their own pace of doing things. All right, so that's not a problem. Let's go ahead and give this particular problem a try. And let's see what we get. See if we indeed get this answer. All right, so we're going to take 10.22 divided by 9. So put 9 here on the outside. And 10.22 here on the inside. All right. Again, we'll add a few more zeros here, just to see how far we need to go here. All right, so 9 goes into 10 once. So put a 9 here. And we'll line up these decimals too, so go ahead and place that there. We'll bring down the 2 here, so 9 goes into 12 one time. So that's 9, that'll be 3, be 32. So 9 goes into 32, that'll go in 3 times, so that's correct. All right, got 7, subtracting here, we get 5 and 0, we get 50. 9 goes into 50 5 times, so here we get 45. Here we get another 50. And this is probably going to repeat. So again, we get 5 times here. And this would keep repeating on forever at this juncture. Okay, now, since we're rounding it to the nearest thousandth, as we can see here, we have 1.1355. So here we got a circle here, 5. We'll underline that 5. Again, we're going to round this up by 1 because we have a 5 to the right of that one. So that answer is correct. 1.136 is going to be our final result for this particular problem. Okay, good. Any questions about that? No? Let me look at that. Okay. Okay. So let me check something here really quick. I want to actually get a actually want to get a poll here really fast. So let me check something here. Okay. Okay. All right. Okay. So let's all right. Okay. So I do have a quick question for you guys. So I would like a kind of a democratic process on this. How many of you need a little bit more time of which to finish the homework? Let me. I'm just talking about so what I'm talking about here, Hannah, is the homework from chapters 2 and 3. Um, because that was the last test there, so I'm just talking about the homework from chapters 2 and 3 specifically. The homework from chapter 4 is okay. How many people need a little bit more time? Okay, so Yvonne, excuse me. Yvonne says, got that done. Anybody else want to kind of mention that in the chat there? How many people need a little bit more time to kind of finish up there? Okay. All right. Anybody else want to say anything or no? Because I'm going to make a decision then. All right. So what I'm going to do here, do you need? Okay, that's fine. Okay, so what I'm going to do here is then I'm going to extend that chapter 2 and 3 homework here out for a little bit of time. So let me go ahead and do that. Okay, so this, and this, that, and that, that, and that, that, and that. Okay. So, actually, those are already set, aren't they? All right. Okay. So I'll just change this due date here to, okay, there we go. There we go. All right, there we go. I reset the date there for the chapter 2 and 3 homework. That will be due on the 1st. So that'll be due on the 1st of November. Okay, so I made it out to like 11, 12 days from now. You have plenty of time to get that done, so there shouldn't be any complaints about that. If you haven't finished the chapter 2 or 3 homework yet, then this is a good opportunity for you to do so. Okay? All right. The homework has been extended out to Thursday, and the chapter 2 and 3 test has been given out until November 1st. All right. Now, um, one other thing that we will need to talk about here is let's talk about what we're going to be doing here next time. Next time, we're going to be dividing by decimals instead of just regular whole numbers. So we're going to talk about that for next time. So that's kind of like the latter half of this particular chapter. There's just a lot going on in this particular section. So we're going to spend a little bit of time just kind of going over a lot of these different type of problems. And then we're going to do order of operations with decimals because we really haven't talked about that yet. And we may end up doing, I may talk a little bit about section 4.6, which is a completely optional section. I'm not going to go, I'm not obviously going to go over all of it, but at least a different way to kind of think about numbers and decimals and whatnot. So I may go ahead and just talk about it a little bit, but may not just test you on it per se. So, all right. So that is our agenda for right now. Okay. Are there any questions about today? Any questions about today's material? Okay. Okay. So that's where I'm going to leave off here today. I want to thank you all very much for coming on out to the stream. If you want to stick around for the 11 o'clock stream, I'll be back in about 10 minutes or so. So to do another pre-algebra stream here. But if not, then that's perfectly okay. I will go ahead and log off here for you guys for the 9:30 class here until Thursday. Okay? I wish everybody a good day. I'll be back in 10 minutes if you'd like to stick around. All right. Have a great one, everybody, and we will see you all later. All right. Take care. All right. Bye.